Okay, in this last example, we're going to take a look at what's called joint variation. And really, joint variation means that you, in the problem, could have some direct variation. You could have two variables that are controlling the variation, or you could have actually a direct and an inverse variation happening at the same time. You could have, all sorts of mixes and combinations. So let's take a look at this example and see how this is going to work. Okay, the volume of a mass of gas varies directly to the temperature and inversely to the pressure. So the way that I like to remember it is that when it says it varies, that means we're going to have a constant. Okay, directly means we're going to be multiplying the temperature, and inversely means that we're going to be dividing by the pressure. Okay, so here it gives you some information, but let's first write down the equation that we can use. So the volume of a gas is directly proportional to the temperature. That means I have some constant times my temperature, but it's inversely proportional to the pressure, so that means we divide by P. So this is the equation I'm going to be using, and now what I need to do is use my given information. So my given information says that when the volume is 231, so the left side is 231, we have K, which we're trying to find. When the temperature is 42, so I multiply here 42, and the pressure is 20, I should be able to go ahead and figure out what our constant of variation is. So let me go ahead and do this. I'm going to multiply both sides by 20 first, so 231 times 20, and then I'll divide both sides by 42. And what I get is that 110 is equal to K. So remember, I multiply both sides by 20, got my answer, and then I divided both sides by 42. So there's my constant of variation. So now that tells me that my volume is 110 times the temperature over the pressure. Now we can answer the question, what is the volume when the temperature is 30 and the pressure is 15? So I'm going to plug in 30 for T and 15 for P, and I should be able to get V. So V is equal to 110 times temperature, which is 30, and divided by pressure, which is 15. And if we compute this, this will come out to 220. And since it's volume, it'll be measured in centimeters cubed, just like this volume was. So you can see in this problem how you had a combination of both direct and inverse variation all happening in one problem.